Okay, same chapter. Kinematics. And we have done derivation of distance, DRS, initial plus final speed divided by 2 times t. And then next one, V is equal to U plus AT. And the next is distance S or D is equal to UT plus 1 by 2 AT square, and the next V square U square plus 2S, where V is the final speed, U is the initial speed, A is the acceleration, S is the distance, and definitely the small t is representing the time taken by the object to cover some distance. So these are the equations. Now, if these equations are used, make sure that acceleration is constant. So these equations are valid when acceleration is constant. Now, if the object is falling in the absence of air, or air resistance is there, but it is negligible. Air resistance is negligible. Now, when air resistance is negligible, so we have to calculate the air resistant force, which is the drag force of the air, and its formula is CRV. V is the speed, R is the radius of the object, and C is the constant. And this formula is also written as 6 pi eta RV, where eta is the viscosity. If this force, the drag force, means the air resistance force, F, the drag force, is smaller than the weight of the falling object, then air resistance is ignored. But if the drag force of the air, the resistance force of the air is greater than or equal to the weight of the falling object, then we have to consider it. Okay, now we start with negligible air resistance, either no air, vacuum, free space, or air resistance is negligible. Then the only force acting on the object during the fall is its weight. When the object is falling down, weight is the accelerating force. So the weight is equal to mg, thus the acceleration is w divided by m, and this is the acceleration due to gravity. When the object is thrown up, weight is opposing the motion. So this is the retarding force. So here, the weight is retarding force. And the retardation G is equal to, again, W by M, weight constant, mass constant. So G is constant. And in A level, it is taken 9.81 meter per second square, or we can write 9.81 Newton per kg. So in the absence of the air, the weight is the accelerating force, which is constant. Weight is the retarding force, which is constant. Hence, the acceleration is constant, which is equal to G. Then, the equation number 1, which is V is equal to U plus AT, will be in this shape. For the downward motion, it is V is equal to U plus GT, and for the upward motion, V is equal to U minus GT. Instead of acceleration, we will write G. For the downward motion, it is accelerating. Acceleration is positive. Upward motion, retarding force, retardation, so minus G. And the next equation, which is S is equal to UT 1 by 2 AT square. For the upward motion, it can be written as S is equal to UT plus 1 by 2 GT square. And for the downward motion, S is equal to UT plus, we have to write minus T, so right here, UT minus 1 by 2 GT square for the downward motion. And similarly, the third equation, which is V square U square plus 2AS, for the upward motion, it will be V square U square plus 2GS, but for the downward motion, V square U square minus 2GS. So look at the equation for the free fall, upward and downward. For the downward, plus G in the equation, and upward in the equation, negative G. Now, next, linear motion. So this is linear motion. This is linear motion. This is linear motion. This is linear motion in one direction. So if the acceleration is constant, we will use above equations. Now the graph, for example, number 1, the motion is represented by this graph. Time at the x-axis, speed at the y-axis, and the graph is this. We have to describe the motion. Look, the motion is object is moving with the constant, with the uniform speed. Speed is constant, velocity is constant. So we can write the acceleration of the object is 0 and distance is covered. So the speed is constant, acceleration is 0, distance is covered, and we have to draw acceleration and distance graph. So time at the x-axis acceleration at the y-axis. For this motion, the acceleration is 0. So this is the line. 0 acceleration. When we have to draw the graph for distance s in meter against time. Now do remember, the gradient of distance time graph is speed. So speed is constant. So we have to draw here a constant gradient line. So this is the graph. So this is number one. When the speed is constant, acceleration is 0, the gradient of distance time graph is this. I mean, the distance is increasing uniformly. This is the first one. Now the next motion, number 2. Suppose the graph T and V is this straight line passing through the region. So what is the motion? Number 1, it starts from rest, initial speed 0. Number 2, it accelerates uniformly. So it starts from rest and accelerates uniformly. Definitely, it is covering distance. Now, we have to draw the graph for the acceleration for this motion. So time at the x-axis, acceleration meter per second square here. The gradient of the graph, the gradient of the speed and time graph is acceleration. It's a straight line. The gradient is constant. Hence, the acceleration is positive and constant. So this is the graph for the acceleration. And the next, we have to plot distance covered against time. So this is distance, DRS in meters. The gradient of the distance time graph, is speed. Look, the speed is increasing. So this gradient must be increasing. Speed is increasing uniformly because acceleration is constant. So the graph for this will be uniform. Initially, the speed is 0. So we have to show initially the 0 gradient, and then we have to increase. It's a curve. So this is the graph for this linear motion. And do remember, the gradient of this graph is equal to acceleration. Number 2, the area of this graph is the distance covered by the object. And here, the gradient of this graph is nothing, but the area is equal to speed. Do remember, if initial speed is 0, then the area is equal to final speed. And if initial speed is not 0, then the area is equal to change in the speed. Do remember? And here, the gradient of this distance time graph is the speed. And area under the graph is nothing in the physics. Okay, so the next, number 3. if this is the motion, time at the x-axis, speed in meter per second at the y-axis, and the graph is a curve, then the motion is, it starts from rest, speed or the velocity increases, but non-uniformly, and the acceleration is gradually decreasing because the gradient of the graph is decreasing. And if the line finally becomes the horizontal, then the gradient is 0. So acceleration finally 0. Now we have to plot the graph for acceleration. Time here, speed here, meter per second. Look, initially, the gradient is maximum. So that, here we have to draw the graph for acceleration. So initially, the gradient is maximum. So acceleration maximum. And after this, line is straight. So the gradient is 0, acceleration 0. So if the curve is uniform, then we can draw the straight line down. If the curve is non-uniform, then we can draw this one. So in both cases, the acceleration is decreasing, and finally it is becoming 0. So here the acceleration is decreasing. Velocity is increasing, but the acceleration is decreasing. And the acceleration finally is 0. Now the time at the x-axis and the distance at the y-axis, the graph, look at this speed. Speed is increasing. And finally, the speed becomes constant. Initially, the speed is increasing and finally becomes constant. So here, initially, the increasing gradient, 0, increasing gradient. And then we have to draw here a straight line for this portion. Speed is constant for this portion A and B. So this is A, this is B. Speed constant, gradient constant. And here, initially the speed is 0. That's why the gradient initially at the start is 0. Next, number 4. If the motion is represented by this graph, so initially the speed is 0, object starts from rest, its speed increases non-uniformly, and acceleration is gradually increasing because the gradient of the curve is increasing. It is becoming more steeper. Then the acceleration and time graph. Look, the gradient initially 0. So initially the acceleration is 0. So this is the point. And then its gradient is increasing. Its gradient is increasing, mean acceleration is increasing. It's a smooth curve, then we can write this. If it's a smooth curve, then this. So acceleration is increasing uniformly. So this is a graph. And the distance time at the x-axis, distance at the y-axis. Initially, the speed is 0 and the speed is increasing. So the gradient of the graph increasing. So this is the graph. The gradient of the line is increasing, initially grading 0 because the speed 0. Then speed increases, so this increases. And number 5, if the motion is represented by this graph, speed at the y-axis, and the graph is this. Now here, speed is decreasing. Speed decreases uniformly, mean deceleration. Retardation is constant. And the final speed becomes 0. Then the graph for the acceleration. Now this is negative. So this side positive, this side negative. This is acceleration. This is time. So this is negative graph, but constant graph. So this is the graph for the acceleration. And its distance time look, the speed is decreasing. So we have to draw a decreasing gradient line, and the decreasing gradient line will be this. And finally, gradient becomes 0, horizontal line, because this is the speed 0. So this is a graph. So this is distance time, this is acceleration time, this is velocity time. Okay, now the number 6. Number 6 now. This is speed against time graph. And if the graph is like this, so speed decreases non-uniformly, mean retardation is not constant, and the final speed is 0. So for this, we will draw the graph. We will sketch the graph for acceleration like this. Time here, acceleration here, 0, this side positive, negative, and look, initially the gradient is 0, finally the maximum. So this is the retardation, straight line. Initially 0 retardation, finally increasing. And the distance time graph look, the speed is decreasing. Initially, the speed is maximum, so the gradient maximum. So the graph will be similar to this, and finally it becomes 0. Because the gradient of this graph is equal to speed. So these are the 6 graphs we have to remember initially. Now, if the object is falling or rising, equations are V is equal to U plus GT for the downward motion. And for the upward motion, V is equal to U minus GT. This is the concept for equation. Because from the equation, we are calculating only the magnitude, not the direction. we are calculating only the magnitude from the equation. So for the downward motion, the magnitude of the speed increases, so it is plus g. For upward, the magnitude decreases, so it's minus g. But very, very important, if we are not using equation, we are discussing other than equation, then do remember acceleration is a vector. It has magnitude as well as direction. So we have to consider both. But when the object is moving down, its speed increases. So the magnitude plus and mean multiply in math physics, and the direction downward suppose taken positive. So this is positive. So downward, positive into positive, this is a plus g. But when the object is thrown up, the acceleration is equal to r. It is represented by magnitude and direction. Object is moving up. So the velocity upward decreases, so minus sign and multiply. And we are taking downward direction positive. Down direction is taken positive, but we are throwing it up. So this direction is negative. So in this case, negative into negative, it becomes again positive, so g. So look, if we are not using equation, we are discussing other than the equation, we are not calculating any numerical value, we are drawing graph, we are discussing the motion, then for upward motion, it will be plus g. For the downward, it will be again plus g, because acceleration is a vector. We are considering both magnitude as well as direction. But here in the equation, we are using only magnitude. So when we are using magnitude, downward positive, upward negative, but when we will consider both together, up positive, down is also positive.